All right, today we're going to continue with our measurement unit and demonstrating an understanding of the big idea that has to do with being able to measure objects according to one attribute. Our attribute today is volume, and being able to compare them by using volume. So, what is volume? First of all, volume is the amount of space inside an object. Okay, so for example, how could you find out how much space there is inside this shoebox? Well, you can find the volume of a box by filling it with identical items and then counting them. That would tell you how many of that fit into that box. So for example, if we wanted to find out the volume of this box of chalk, and we filled it with chalk sticks, they're exactly the same, they're all the same kind of chalk stick, and it holds 144, then we could say the volume is about 144 chalk sticks. We use about when we are estimating. An estimate is there because the items don't fill all of the space. You'll notice there's a little bit of space in between each chalk piece at the top there, so it doesn't quite fill all of it, so then we have to say it's about, which makes it then an estimate. This box, for example, holds 80 sugar cubes. The sugar cubes fill the box without leaving any spaces, therefore this is not an estimate. That probably should have been on the last page. Okay, this is not an estimate because there are no spaces. So for this one we know the volume is 80 sugar cubes. When we are trying to be more exact, which mathematicians usually are, we measure volume using centimeters cubed or meters cubed. That means we are filling it now with cubes that are 1 centimeter along each edge in order for it to be a 1 centimeter cubed measurement. So 1 centimeter cubes. If you think of those little yellow cubes that we have for place value, the place value cubes, the ones unit, that's about a centimeter cube. All right, if we were to look at this box here, we can see that this box has 4 rows of 6 cubes, and they're only 1 cube high. So if we were to count how many cubes 4 rows of 6 would give us 24, because 4 times 6 is 24. Because there's only 1 row times 1, which then gives us 24 centimeters cubed. Sometimes we have objects that are irregular. They're not a specific kind of a shape. And we can still count the volume by figuring out how many cubes there are. So if you look at this one, for example, there are 4 cubes along the bottom, 2 cubes deep, 1 cube high. So that layer is 4 times 2, which is 8. So 8 in that bottom layer, and we have 1, 2, 3 on the top. So 8 plus 3, which makes it a total of 11 centimeters cubed for this one. For grade 5, what you're mostly responsible for is the volume of rectangular prisms, and this would be a rectangular prism, a box basically. I mean, in this case there are 2 rows of 4 cubes. So for our top layer, 4 times 2, there's 8 cubes in our top layer. And it looks like it holds 2 layers. Can't really tell from the picture, but we can from the description. So there's 2 layers of 8. Well, 8 plus 8 is 16. Or we could have just gone 8 times 2, which is 16, which is where our formula ends up coming from. It ends up being length times width times height, which you can see if you multiply the length of 4 times the width of 2, 4 times 2 is 8, multiply that 8 with the 2 that is the height, 8 times 2 gives us our 16. Now it's time for you to practice. Do remember what our formula is here, length times width times height, as this doesn't have cubes that you can count. However, it does tell you the length, the width, and the height. And remember, it does not really matter what order you multiply them in. The name for this is what we call the commutative property, so it doesn't matter what order you're multiplying them in. Remember to press pause and go ahead and try it. All right, let's go ahead and give them a try. Remember, your formula is volume equals length times width times height. For grade 5, you don't necessarily need to know the formula. In grade 6, you will. The formula tends to be helpful, so I give it to you anyway. When you write the formula, I would highly recommend that you write the V in front of it, just so that it helps you remember that this is volume and not area and perimeter, which can end up getting mixed up later on. So our volume then is length times width times height for the first one, 2 times 2 times 2. Well, 2 times 2 is 4, 4 times 2 is 8, so it's 8 centimeters cubed. And to show that it's cubes, we use the little 3, okay, making sure that that 3 is there. Let's try it for B. Again, volume equals length times width times height. Volume then is 5 times, actually technically that would be 4, but again, due to the commutative property, it really doesn't matter. 4 times 3 times 5, 4 times 3 is 12, 12 times 5 is 60. In this case, it is meters cubed. From here we move on to, can you make rectangles, rectangular prisms, I suppose, rectangular prisms with a given volume? So if I asked you to use, for example, 11 cubes, how many rectangular prisms could you make? What could be your length, your width, and your height? 11 is a tricky one because 11 is actually a prime number. There is no way that we can make it other than one big long cube of one layer. However, if we try it with 12, it's much easier. We can have 3 numbers that multiply to equal 12. So we could try a few things. Well, 12 divided by 2 would be 6. So I would have, I could have one layer by 6 with rows of 2. And that would be this one here, actually. I could also have the fact that I know 2 times 3 is 6, and I'd need 2 layers. 6 times 6 is 2, so another group of 2, which would be 12. That would work as well. I could have 3 times 4, which is 12, and one layer, which would make it 12 still. So that would work, and that would be this one here. So there's a lot of different possibilities. This can be a little bit tricky to do. Your best bet is to divide by a number and then divide by another number with whichever numbers you have. So for example, I took 12, I divided it by 2 to get my layer of 2, which meant I had 6 left. So I went, well, 1 times 6 can equal 6. Or 2 times 3 can equal 6. So that's kind of your best bet for doing that. You're going to practice some on the next screen. All right, at this point you're going to press pause, and I would like you to try to create a rectangular prism with a volume of 32 centimeters cubed. Tell what your length, your width, and your height will be. Once you've found one, try to look for another one. If possible, not just one big long row of 32. Challenge yourself to think of something a little more complex than that. All right, and I hope you remember to use your calculator if you're at all needing it. In this case, 32 is the volume we're looking for, so we need something times something times something, that's 32. I'm going to try 32 divided by 2, which gives me 16. So one of my dimensions is going to be 2, and then I need my other 2 dimensions to multiply to equal 16. Well, what can multiply to equal 16? Well, 4 and 4. So I could have a rectangle that has a length of 4, a width of 4, and a height of 2. A rectangular prism, excuse me. What else could work? Well, I could have 2 still, and 2 more numbers that multiply to equal 16. I could have 2 times 8, that equals 16. I could also have still 2 times 1 times 16. I could have one row of 16 and 2 layers of that. I could try 32 divided by 4, which is 8, so one of my dimensions is 4, then I need 2 more dimensions that multiply to equal 8. Well, I could have 4 times 2. I could have 4 and then 1 times 8. That just gives you an opportunity to see that there's lots of different possibilities. All right, at this point, you're going to go on to do some practice. Your concept practice today is in your textbook, page 140, numbers 6 and 10, and page 143, numbers 1 and 2. Go ahead. Remember, before you begin, if you have any questions, to please ask. And remember, you're welcome to use your calculator, but you must write down what it is that you are punching into your calculator as your work.